Write an algebraic equation and use it to solve the problem. A college student earned $7,000 during summer vacation working as a waiter in a popular restaurant. The student invested part of the money at 10% and the rest at 6%. If the student received a total of $548 in interest at the end of the year, how much was invested at 10%? Okay, the problem at hand here is involving a student who has some money to invest. And we're seeing words like interest and rates of return like 10% and 6%, etc., and how much interest will be received by the student. So what we have here is the assumption. We're going to have to make an assumption that the type of interest being calculated is simple interest. So we're looking at interest here, and we're going to assume simple interest. We have to make some assumptions if they're not clearly, like, totally spelled out, and which is fair to do. Okay. Now, when we're talking about simple interest, we have to be aware that simple interest is calculated by a formula known as I equals PRT. I equals P times R times T. I is the amount of simple interest, and that's an amount of dollars. Amount of simple interest in dollars. Then P stands for principal, which is the amount of money that's deposited either into an account or the amount of money borrowed. I mean, all of this can be used for loans or investments. This formula, I equals PRT. R means rate, and that's usually expressed in percent per year. And that's convenient for us because we are seeing the unit of time that's elapsing as a year. And then the time itself, T, means time. And we need to make sure that, if they were to ask us how much would he earn at the end of 6 months, well, months wouldn't be compatible with year because we're about to multiply these things together. We'd have to convert 6 months to 0.5 years, like a half a year, and make sure that the unit of time in the T factor matches the unit of time in the rate factor, the denominator of the rate factor. Okay? But this all looks pretty good. So we have the basis of our problem here, and we'll be able now to start assessing how to work this problem. All right, the student has $6,000 to invest. Excuse me, $7,000. Just read and reread the problem until we assess it properly. Okay, the student has $7,000. I'm gonna make a tree. The student has $7,000 to invest, and he has 2 branches of his investment. This student who's worked as a waiter, he has some money that he's going to invest at 10%, and so we don't know how much money that is. What we basically are looking at is a P, an R. We have 2 investments that we're going to come up with. We have a P, an R, and a T. This branch is going to be the 10% per year branch. Then he has the rest of his money that he's going to put into some other investment that's also going to be calculated under PRT, where the rate of return for the second part of his investment is 6% per year. Okay, so these are the 2 parts of his investment. To distinguish these parts, P, R, and T, that are grouped together, I'm going to say here in investment 1, I'm going to use subscripts P1, R1, and T1. And we're going to just call this investment 1. Investment 1. So that all these subscripts P1, R1, and T1 all go with investment 1. And these other ones are going to go with investment 2. We don't know whether these investments are stock versus money market. We don't know. We're just going to call them investment 1 and investment 2. Investment 2, the P, R, and T I'm going to give them subscripts of 2. So we know that these values go with investment 2. Okay. We know that the time that he's going to use for each investment, he's going to let them sit in these investments for 1 year. Because they say at the end of 1 year. At the end of the year. So time 1 and time 2 are both 1 year. 1 year long. Now, they're not telling us how much he's putting into the investment 1. So we're just going to say, I don't know. I don't know how much he put in here. But we can calculate, we can come up with an expression of how much he would have left out of his $7,000 for investment 2. If he has $7,000 to begin with, wouldn't what he would have left would be, for investment 2, is take away from $7,000 the amount of money he put into investment 1. So here's the expression we can use for how much money did he put in investment 2. Well, the total of $7,000 take away, which is like what some people use for subtraction when they see subtraction. 7,000 take away what he put in investment 1. Okay, furthermore, they want to know if between the investment 1, how much you put in investment 1 and investment 2, they're actually asking us how much did he invest at 10%. And for us, the way we have the problem set up, that is what we've assessed, what we've defined to be P1. So by the time we get done, if we can solve for P1, this will be the answer to the problem that they're looking for. Okay, now let's get down to our cases here. And what we can do now is use the PR and T's that we have here to find out, to calculate how much interest did he actually get from investment 1. Remember how I stands for the amount of simple interest earned, or that I owe, you know, if this was a loan. And we're going to also calculate how much interest he earned out of investment 2. Well, if we add those two amounts of interest together, we should get a total. See where they're saying here in the problem, he should be getting a total of $548 in interest. And this is very useful. I1 comes from P1 times R1 times T1. And I2 comes from P2 times R2 times T2. These two sets of factors, we can start substituting in things that we know. Okay, first of all, 10% is, we shouldn't use percents as percent when we're using them in multiply. If we replace the percent sign with divide by 100, this rate becomes 0.1 per year, and we mean per 1 year. When someone says per year, they mean per 1 year. 6% per year, we're going to do the same. 6 divided by 100 makes 0.06 per 1 year. Per 1 year. Okay, now we have the percents converted to decimal. P1, we don't know what P1 is, so we're going to leave it as P1. But we're going to have to multiply it by R1 is 0.1 per 1 year times T1, which is 1 year. Okay, P2. We don't know what P2 is other than to say, let's go ahead and replace P2 with 7,000. I'm going to take out units. Well, no, let's leave them in. $7,000 minus P1. Let's see what happens when we leave those units in. R2 is 0.06 per 1 year times T2 is 1 year. Okay, I'm gonna draw lines so you can see where these are. P1 is, we're leaving it as P1. R1 we replaced with 0.1 per year, and T1 is 1 year. P2 is all of this expression, 7,000 minus P1. R2 is 0.06 per 1 year, and T2 is 1 year. Now, here is the plus sign between these two terms. Here's the equal sign that totals of $548 of what he should be getting at the end of 1 year. Okay, what we have here is an equation in one variable, P1. We can definitely solve this equation and get P1 equals a number, which is the goal of solving an equation. So we're gonna solve this equation for P1, and in the end, our goal is to get P1 equals a number, and that number should be the answer. P1, of course, we need a positive 1 P1 on the left side of this final goal equation, and then the number should be the number of dollars that he invested at 10%. Okay, if we start simplifying now, first of all, when you have a fraction in the middle of two other things that are not fractions, we've got to turn those other two things into fractions by putting them over 1. And when, you know, in the second term, we're going to do the same thing. Then how do we multiply fractions? We multiply straight across. So when we multiply straight across, everything gets connected, you know, the numerators and denominators with multiply. With multiplication. Multiply straight across, the numerators and denominators are connected with multiply. Furthermore, between a unit of measure like 1 and year, there's also the existence of multiplication. It works out really well to consider multiplication between a number and its unit of measure. What happens at that point is we can consider identical units of measure, like year and year, to be identical factors, common factors between the numerator and the denominator. They divide each other out and leave ones behind. That's very useful for us in this problem because it explains where the term of years goes. They divide out, and they divide out correctly. So what we have left is 0.1 times P1. You know, if I just do commutative property of multiplication, 0.1 times P1, everything else is a 1. Over 1 goes away. Plus, in this big fraction, what we have left is 7,000. We go ahead and remove the dollar sign. Everything agrees. This is an amount of money in dollars. This is going to be an amount of money in dollars, and added together is another amount of dollars on the other side, a total amount. So I'm going to eliminate the dollar sign, unit of currency. What we have left on this right term is 7,000 minus P1 times 0.06. Everything else is a 1. Over 1 goes away. Equals, I'm going to also eliminate the dollar sign from the right side. Now we have a set of parentheses. And how do we remove parentheses? We remove them by distributing. So we're going to distribute this 0.06 to each of these two terms. And I'm going to go to calculator, make sure that I execute this multiplication correctly. 7,000 times 0.06. 0.06 equals 420. So these guys, this term times 0.06 is 420. And of course, positive times negative makes negative. 0.06 times P1, 0.06 P1. Okay, there's what we get from distributing to each of these two terms. Now, plus 0.1 P1 equals 548. Now, what we have here are like terms. We have P1 to the first and P1 to the first. What we have is 0.1 P1 minus 0.06 P1. So when we bring these together, it's 0.1 P1 minus 0.06 P1, and then I'm rearranging a little to bring these like terms together, plus 420 equals 548. Of course, when you have like terms like P1 to the first and P1 to the first, all we do is add or subtract their coefficients. 0.1 minus 0.06. 0.1 in my calculator minus 0.06 equals 0.04, positive 0.04. 0.04 P1 plus 420 equals 548. Now we've got all the like terms combined, and I'm going to subtract 420 to eliminate the constant from the left side, and I'm going to subtract 420 from the right to balance the equation. What we do to one side of an equation, we do to the other. On the right side, we have 548 minus 420 equals 128. 128. 0.04 P1 plus 0. This makes 0.04 P1 equals 128. Okay, let's bring this up here. Just have a little more room to work. I haven't done anything yet. 0.04 P1 equals 128. Okay, now the last thing we need is, of course, to convert this. We need to change this 0.04 to a 1. This is not finished. We haven't finished solving it yet because the coefficient of P1 is not a 1. The coefficient is a 0.4. How do we take anything, divide by itself, anything, and turn it into a positive 1? We take it and divide by itself. 0.04. Divide by 0.04 makes our positive 1. P1. And to make this happen, we divide it by 0.04 on the left side. Well, of course, we have to do the exact same thing to the right side to keep the equation in balance. So I go to the calculator. 128 divided by 0.04 equals 3,200. Equals 3,200. And here is the number that we're looking for. And we have the left side looking just like our goal, 0.1, positive 1, P1. This should be the amount of money that was invested into at 10%. And there's ways to check this. We could continue by calculating. This would be the answer I would look for. But before I do, I just want to make sure, if we were to take P1 as in this expression right here and replace it with 3,200, it'd be one way to check, is if we put in 3,200 here, we could find out how much the student invested in the 6% investment. So what would that be? 7,000 minus 3,200 equals 3,800. Now the proper way to check this is, here's P2. We would come down here where we have P2 and replace it with, I might just do right over it, P2, CP2, replace this with 3,800. And here where we have P1, we would replace this with 3,200. And see if after we multiply 3,200, I'm going to go ahead and do it right here. 3,200 times 0.1. 3,200 times 0.1. What do we get? 3,200 times 0.1 is 320. This makes 320 plus, okay, 3,800 times 0.06. 3,800 times 0.06 is 228. 228. Now, when we add these together, 320 plus 228, look at what we get. 548. There's the proper check. That his two individual investments total together to make 548 when we factor in the two individual rates, the 10% that goes with 3,200 and the 6% that goes with 3,800. So I feel very good now that this is the correct number for P1. How much money did he invest at 10%? We look at the answer choices and we find the correct answer that we've already checked. The correct answer is C.